Hello, we're going to talk about the properties of numbers in this video. When we refer to numbers, we are talking about real numbers. So the numbers that we talked about in the previous section, 1.01. And some of these properties are going to help us decide how to manipulate the numbers in the correct way so we're all on the same page when we're handling equations and trying to simplify. So that's why we got this little meme here. If you put jelly first, is it a jelly and peanut butter sandwich? Well, we know that if we put jelly first and peanut butter second, it's still going to be a peanut butter and jelly sandwich. So the order doesn't matter in which we put them on, unless you believe it does matter. But that's kind of like one of the properties that we're going to get to experience today. So the first one's pretty simple, the reflexive property. Any number is equal to itself. So you take a real number, it's going to be equal to another real number. Some examples down here, we're always going to show a little algebraic one. So A is equal to A. A represents a number, any number. So that's what a variable is. It's a letter that's being used to represent a number. And then some number examples there. Okay, the symmetric property is kind of similar to the reflexive property, but we're saying that we have two different things that are equal. And we're just saying it doesn't really matter which side you put them on the equal sign. So if x is equal to 3 plus 4, well, then you could also say that 3 plus 4 is equal to x. You could flip them around over the equal sign. Same kind of thing over here. 2 times 3, that's what this is. It times, when there's no symbol between two things. In algebra, we say that's multiplication. But that 2 times 3 is equal to 6. Flip that around, 6 is equal to 2 times 3. Same kind of thing. The transitive property. So this is when we've got three things that we're working with. So typically we say A, B, and C. Now we say if A is equal to B and B is equal to C, notice that both of these things are both equal to the B value. A is equal to B, C is also equal to B. Well, then that must mean that A and C must be equal to each other. Okay, that's the transitive property. Here I color-coded this one. If 10 is equal to 4a and 5b is equal to 10, notice that blue is equal to the orange value and green is equal to orange. So since this orange 10 is what connects these two together, so therefore 4a must be the same as 5b. They're the same over here. This is another example with numbers. I messed up the color coding over here. I was supposed to put orange on 4 squared and 4 squared here. So if you ignore the coloring, it does work here though. Substitution property. So this is another equality property. If we have two numbers that are equal to each other, that means one can be substituted in place of the other. So here we have x is equal to 15. So this is an equation. We have an expression over here with x in it. Well, since we know that we have an equality over here, we can substitute 15 in place of where the x is. So notice that where the orange x is, take it out, place the 15 in there, and this is okay. We can do that. Notice though, when we plug in the number 15, there's parentheses. It's kind of covered up there, but we plug it in with parentheses so that we can show that it's multiplication. Same kind of thing here. 0.25 is the same as 1/4. If we have an equation here with 1/4 in it, we could replace that 1/4 with 0.25 because they're equal. The identity property. Now there's two versions of the identity property. There's the one of addition and one for multiplication. So each of these operations, right, that's what we call these operations, they have an identity. And this identity, when you use it, you just get the same number as before, the original number. So when you add with 0, you get that original number. When you multiply with 1, you keep that original number, whatever it is. That's because the identity of addition is 0, and the identity of multiplication is 1. So we have two different identities depending on which operation you're using. And that's, again, because whenever you add, I don't care what the number is, you add 0 to it, you're going to keep that original number. So 4 plus 0 is 4, x plus 0 is x. This is a little bit different variation example, so we're not going to look at that one too much. But same kind of thing with multiplication. 1 times anything is going to bring you back that other number. So 1 times x is x, no matter what x is. 1 times 7, or 7 times 1, is 7. Okay. Again, this one's kind of, if you put the 1/2 with the 2, that makes 1. So 8 times 1 is equal to 8. That one's a little more complicated. Same thing over here. If you were to add the -1 and the 1, you get 0. So that's how you can get 0 involved in this example. We also have inverse property of both addition and multiplication. Now this is kind of similar to the identity property, but the identity value is the answer in this property. So it's when we're talking about addition, when you add two things, two numbers, and if you get the identity, then that's the inverse property. So if you get 0. Now, what kind of numbers add up to make 0? Well, they're opposites. So like 2 and -2 are opposites, or x and -x. So if you add them, you get 0, the identity element. 7 plus -7 is 0. Multiplying, it's not opposites, right? We don't multiply negative and the positive version to get 1, right? Because we want to get 1 with multiplication, because that's the identity. But what we have are reciprocals. Okay, reciprocals. Hopefully you recognize that word. That's a fraction, the flipped version of a fraction. So 7 over 8 is 8 over 7. A little trickier is like this one, 1 over 4. You'd think you should see 4 over 1. Now, just be careful there. Whenever you have a denominator of 1, we typically don't write it. So whole numbers all have an invisible denominator of 1 underneath them. So yes, these are reciprocals. When you multiply reciprocals, you get 1. Same thing here, 1 over 7 times 7 over the invisible 1, you get 1. Now, an interesting thing here is really these are the main two operations. Now we also have subtraction and division, but subtraction is derived from adding opposites, okay, adding negatives. So that's where subtraction comes from. We don't really need to have subtraction. We could just add all the time and just use negative numbers. But it's easier sometimes to talk about math with subtraction, so that's why we have it. But that's where subtraction comes from. Also, with division, division comes from multiplying by these reciprocal numbers. So you can take a divided by b. That's the same thing as if you took a times the reciprocal of b. Yep. Now there's one number that you actually can't do this with multiplication, and that's the number 0, right? There's no reciprocal of 0. If you've ever tried, typing in your calculator any number or like 1 divided by 0, it's going to give you an error message. So this multiplication inverse property works with all real numbers except 0. So keep that in mind. The commutative property. You might remember this one. This one basically just says you can add two things. Well, then you can also add them the opposite direction, right? So a plus b is the same thing as b plus a. Here's some number examples: -4 plus 10, 10 plus -4. Multiplication is the exact same way. X times y is the same as y times x. All right, and then a number example as well. So it does not matter the order in which you multiply or add. The associative property. So this is when you have at least 3 things being added or multiplied. Now remember, parentheses are grouping symbols. So this is saying, hey, let's do b plus c first and then add a. But you could do it that way, or you could group a plus b first and then add C. You're going to get the same answer either way. So here's another example. So what I like to think of it sometimes is you're just kind of shifting these parentheses over to get the 34 plus 16 first, and then add 28. Sometimes you might prefer, or it might be easier to add certain numbers together first. So that's why this property is useful. Same thing with multiplication. You can multiply x times y first and then the z. That's the same as multiplying the yz first and then the x. And then a number example there too. The zero product property. This one is easy to remember. You probably know this one already as well. Take any number, multiply it by 0, it equals 0, right? That's what happens when you multiply something with nothing. If you have something and we're going to do it no times at all, then you get nothing. Yeah, that's what multiplying by 0 really means. So there you go. Here's a tricky one, little example. 2 plus 2 plus 2 times 0 equals 4. That's actually true. The mistake that people make is they think that you have to add all these numbers first and then multiply by 0, but actually you multiply before you add. So the order would be multiply the 2 times 0, get an answer, which is 0, and then add 2 and add 2. So anyway, be careful what your calculator says sometimes. The distributive property. Now this is a property that actually combines the use of both addition and multiplication at once. So we have addition going on in parentheses, and then we have a number being multiplied on the outside. To distribute means you take that number on the outside and you multiply to each thing on the inside. Typically we'd have 2 things on the inside, but it could be 3 or more even. But then notice that this is a times the b plus a times the c. You can see that with numbers, 3 times the 2 plus 3 times the x. All right, and some other examples as well. And last but not least, the closure property. So a number set is closed under an operation like addition or multiplication if performing that operation on numbers of the set always gives a number from that same set. So this one I'm going to talk about the real world example. So if you had 2 dogs of the same breed, and if they have puppies, well, you know for sure those puppies are going to be the same breed as the parents. Okay, so it could be like, oh yeah, you have 2 German Shepherds. They have puppies. Well, those puppies have to be German Shepherd puppies. So that's what closure property is. So you have 2 things of the same, you put them together, and then you get another thing from that same group. So here's some examples. Natural numbers with addition. So remember, natural numbers are numbers like 1, 2, 3, 4. If you add any 2 of those, you'll get another natural number. It'll be a bigger one, but it'll still be in the same group. Another example is integers with subtraction. Remember, integers can be negative, positives, it could be 0, but it can't be decimals or fractions. If you subtract any 2 of them, you might get a negative number, a positive number, maybe even 0, but you will never get a fraction or a non-integer. So that's why subtract 2 integers, you're going to get another integer. A non-example would be if you had whole numbers and you try to divide them. So division can often create decimals or fractions if it doesn't divide nicely. A quick example would be 11 divided by 3. 11 and 3 are both whole numbers, but they do not divide nicely. You are not going to get another whole number answer when you divide them. So that's why it's not closed. All right, and that's it for the properties. So what I would like you to do is practice on this Quizlet. There's a little link here, or I'll also have it on Google Classroom. When you practice Quizlet, I'd like you to try the flashcards, where you click on them to.
If you add 0 to a number,
you click on them to flip them to test yourself. I guess you can also click there to get some audio. and I think I did this earlier. I think it starts off where you click and you flip it, but then I also would like you to try the Learn tab, where it gives you something, gives you a property in words, and then you can try to select the correct one. So again, that's work on the flashcards at least one time through. There's 15 cards, and then try the Learn tab. Okay. Good luck.